So now, let us talk about hemorrhage. Remember in the previous video, we talked about hemorrhage to be the condition that leads to anemia. Anemia. The condition that leads to anemia. So hemorrhage can be divided into two types. There is external and internal. External, this is outside bleeding. Internal, inside bleeding. So external can loses red blood cells to the environment, meaning since there is a loss in the red blood cells, it also means there is also hemoglobin losing. Since there is hemoglobin losing, there is also the heme lost. Since there is the heme loss, it means iron is being lost. So hemorrhage can lead to iron deficiency anemia. Iron deficiency anemia. What about internal hemorrhage? Bleeding inside the body, where the vessel become damaged. So bleeding inside, can it lead to iron deficiency? The answer is no, it can't lead to iron deficiency. Why? Because just like when blood is being lost, okay, those red blood cells undergoes hemolysis process. They are being destroyed. Since they are being destroyed, they release iron. Where? They release iron within the body. Where do you think those iron can go? Those iron can be recycled. They go to the storage room, which is the liver, spleen, bone marrow, so that they can be stored for another synthesis of the red blood cells. So external hemorrhage can lead to iron deficiency anemia. Then the internal, it can't lead to iron deficiency anemia. And we talked about in the previous video, when we classify them in these three, which one is it? Macrocytic anemia or microcytic anemia, or is it normocytic anemia? So when we talk about the external hemorrhage, what can it cause? One, we are losing red blood cells. Okay, as we are losing the red blood cells, meaning the red blood cells are reducing in number. Let's say in the body there, we're just making an example, 1,000, and then we lose 100. It means the remaining is 900. These remaining ones, are they affected in any way, or is its size being affected? No, only the numbers. Only the numbers. So meaning this can be classified as a normocytic anemia because the size hasn't been changed. But when this hemorrhagic continues, it can lead to iron deficiency anemia, just like you've said. So when talking about iron deficiency anemia, what did we say here? Meaning as the bleeding progresses, it can lead to macrocytic anemia. This is the progressive. So when someone continues bleeding internally or externally, this can lead to, we are talking about externally, just it can lead to microcytic anemia. Because where do you think this microcytic anemia coming from? It is coming from the deficiency in iron. So external bleeding, when it progresses for a long period of time, it can lead to iron deficiency anemia. Since it is iron deficiency anemia, this can lead to microcytic anemia. This internal hemorrhage, it can lead to bilirubin presence in the bloodstream and also urobilinogen, it can accumulate, so it increases both here. This is for the internal. Why? Because internal loses red blood cells. Losing the red blood cells meaning the heme is being lost here. I've written the pathway here, meaning the heme lost. As the heme is being lost, meaning the iron and also protoporphyrin is being used, which is just the porphyrin. This is being lost. Then what is this being converted to? It is being converted to unconjugated bilirubin. Then unconjugated bilirubin, it is being converted to conjugated bilirubin. Being converted to conjugated bilirubin. A conjugated bilirubin can react with calcium ion. When they react with calcium ion, what can it cause? It can lead to gallstones. So internal bleeding, it can lead to the destruction of the red blood cells that has been lost. These red blood cells can produce the heme. The heme can produce the porphyrin. The porphyrin can be converted to unconjugated bilirubin. Unconjugated bilirubin can be converted to conjugated bilirubin, which combine with calcium in order to form gallstone. Also, it can lead to jaundice, more especially when the bilirubin is greater than 2.5. Okay, so now how can you treat this? What can a doctor do in order to manage the situation? Blood transfusion in a large quantity. So when you talk about hemolysis, okay, what is hemolysis? So this hemolysis, it is the increase or the destruction of red blood cells. Just like you have said from the hemorrhage, the increase in the destruction of red blood cells, it can lead to the bilirubin and urobilinogen. It can accumulate in the body. So what can cause the hemolysis? One, it is the poisoning, such as the lead present in the bloodstream, mercury, snake venom, and also the parasitic infections such as malaria. It can lead to the destruction or destroying of the red blood cells. This destroying of the red blood cells, it can lead to what? Increase in bilirubin and urobilinogen. And another thing that can cause hemolysis, it is the spherical cells. We know that the normal red blood cells, it is the biconcave with the central polar. But now spherical red blood cells, they have got the shape of sphere-like without the central polar, hence reducing the surface area. So this cell is abnormal. So since it's abnormal, the spleen plays a part in destroying these red blood cells. Since the spleen breaks down this, it releases the iron. Since it releases the iron, meaning it also releases the porphyrin, which can be converted to unconjugated bilirubin and also conjugated bilirubin with ends can also cause the gallstone and also jaundice. So also splenomegaly. So splenomegaly, due to the spherical red blood cells, can lead to splenomegaly because these cells, if they are numerous in the body, they continue accumulate into the spleen, thereby making the spleen to swell. Hence, the spleen does its load. So this can cause jaundice and also can cause the gallstone. Jaundice is mainly when there is too much bilirubin of about 2.5. So let's talk about aplastic anemia. What is aplastic anemia? Aplastic anemia simply means bone marrow failure. Failure to what? To perform its function. What's the primary function of red blood and the bone marrow? To produce the blood cells such as white blood cells, platelets, lymphocytes. Now here our focus is the red blood cell. So aplastic anemia, this is the condition where the red blood cells are not being produced by the disordered bone marrow. Let's talk about hereditary spherocytosis. So hereditary spherocytosis simply means the red blood cells having the spherical shape. Normally with red blood cells, it is the biconcave. Now, a person with the gene that produces this type of spherocytosis can suffer the condition of anemia. And that type of anemia can be also subdivided as hemolytic anemia, hemolytic, hemolytic anemia. Why? Because of the destruction of the spherical shape red blood cells. So now, where do you think this hereditary spherical anemia, what is the pathophysiology? For us to understand the pathophysiology, let us consider the normal red blood cell membrane. The normal red blood cell membrane, it has the cytoskeleton in the cytosol. Okay, and this is the bilayer. So within the bilayer, there are some proteins that are protrude through them. We have glycophorin C and also the band 3. So these band 3 and glycophorin C, that's where the main component of the skeleton, the main skeletal system, which is the spectrin, bind to. So this spectrin, it connects to the red blood, to the bilayer through the ankyrin. So the ankyrin, it binds the spectrin to band 3. Then protein 4.1, it also connects the spectrin to glycophorin. So this is the association. There are two associations. What is that association? It is glycophorin C protein 4.1 spectrin association and band 3 ankyrin spectrin association. So these associations normally makes the red blood cells to be fragile, flexible, such that it can change the shape wherever it is in the capillaries because of its being flexible. So this makes the membrane of the red blood cells to be stable. It stabilizes. But now, in hereditary spherocytosis, this is the situation where a person inherits a gene that do not code for one of these proteins. But what you need to remember, the many important cytoskeleton, it is the spectrin. But the absence of one of these can lead to weak interaction. Weak interaction, it can lead to the red blood cell membrane to lose its biconcave shape, reduced in the surface area, and it become the spherical shape. Since it is spherical shape, what does it do? It causes splenomegaly, the enlargement of the spleen, okay? And it causes this weight can lead to abnormal destruction of the red blood cells. So this is the physiological or the normal membrane structure. So in a situation where there is a defect with the band 3, the defect in ankylin, and also the defect in the spectrin or the protein 41, this can lead to weak interaction. Weak interaction can cause the red blood cells, to lose its bicone shape. Losing its bicone shape, it attains the spherical shape. Losing central polar, its circular, reduce surface area. So this is the many proteins that gives the integrity, that stabilize the membrane of the red blood cells. Deficient in this can lead to spherical shape. Spherical shape can lead to red blood cell destruction, which can eventually lead to anemia. Okay, so next video now we are going to focus on hemoglobinopathies, which is thalassemia and also the anemia. Just make sure if you like this video, subscribe and also click the bell icon button so that you can be receiving these type medical videos each week. Thank you.